video D of the lecture for section 3.3. We're going to find the second derivative of g of x, and before we can do the second derivative, we need to first find the derivative, the first derivative. So let's look at the first derivative of g of x. Now, we've been using the product rule quite a bit, but we're going to be using the quotient rule here because we do in fact have a quotient. So it gives an opportunity to practice that. The quotient rule, remember, we start with the denominator. D comes before the letter N standing for the numerator. So we have the denominator times the derivative with respect to x of the numerator. Between our two statements here, do we add or subtract? Okay, we subtract because if we were dividing terms of the same base, we would subtract the exponents, okay? Minus the numerator times the derivative with respect to x of our denominator. And don't forget that all of it is divided by the square of the denominator. Okay, so this is showing all of the derivatives that we're going to take. Okay, second step is to actually take the derivative. So we have x, and then the derivative of e to the x, we call that as the easiest derivative of all. It is itself. Minus e to the x times, and the derivative of x, if you need to, still need to do this, remember the coefficient is 1, the exponent is 1. Multiply the exponent times the coefficient, so that would give us 1. And then x to the 0, or to the 1 minus 1 power, which would actually give us x to the 0 power. I'll put that in just for a reminder about this. And we have x squared. So to write this out, we'd have x e to the x minus e to the x. X to the 0 is just 1 divided by x squared. We can factor out an e to the x. Let's go back and remind ourselves we need to have a step where we actually take the derivatives. So this would be this step, this would be this step over here. And then we have at least 2 algebra steps. And so we can factor out an e to the x in the numerator, and we'd have x minus 1 divided by x squared. So our first derivative is equal to what we see on the screen, and I'm going to write this so that it looks a little more like a square. Now, are we done? Well, not quite, because it said find the second derivative. So our second derivative, for the second derivative, we might decide that it actually, and double prime can signify second derivative, we might decide that it's actually easier to come back maybe to this step. Now the reason I would suggest this is that here we have just a quotient, numerator, denominator. If we factor out e to the x, we actually have a numerator that is then a product. So we'd have to use not only the quotient rule but also the product rule. So I'm going to opt, I'm going to highlight this, I'm going to opt to take this step simply because it's going to be a lot easier to only do the quotient rule and not to do the quotient and product in there. With that being said, though, I see now that we are in fact going to have the product rule with this term. So I guess we can't really avoid using the product rule, so I leave it up to you, whichever you would like to do. I will still continue to use this. So here we go. The second derivative, and I'm going to mark this as the first derivative so we can see it, is the derivative of the first derivative. So we have from this, using that line, we have our denominator times the derivative with respect to x of our numerator minus our numerator times the derivative with respect to x of our denominator, all of that divided by our denominator squared. Now this is going to get to be rather interesting here, so let's just kind of keep our eye on what we're doing. Here we have, we show the derivatives, okay, so now we've got x squared times, now when I get into this situation, I really have the derivative of this product, so we, as I said, we still have a product here. So we've got now the derivative with respect to x of x to the e to the x minus the derivative with respect to x of e to the x minus the quantity, now we're working on this part, this is the factor, x e to the x minus e to the x, and the derivative of x squared, 2 times the coefficient is 1, so 2 times 1 is 2, x to the 2 minus 1 power, or simply 2x. All of that divided by x squared squared. When you raise a power to a power, you multiply the exponent, so we have x to the 4th. Okay, well, let's see where we're at. X squared from here. Inside here, now this is going to be the product rule. I'm going to just put this in a different color and just remind us that we need to use the product rule on this term. Okay, so this is going to be the first term times the derivative with respect to x of e to the x plus e to the x times the derivative with respect to x of x. Okay, and that's this piece. Let me go ahead, since I have that in green already. This piece right here, I have to use the product rule, and everything in here now is that product rule. First term derivative of the second term plus second term derivative of the first term. So now we're going to continue with our work. We have minus the derivative with respect to x of e to the x, and again the derivative of e to the x is the easiest one. It is just itself. And now we're just going to bring this along. We'd have 2x, the quantity, x e to the x minus e to the x. All of this divided by x to the 4th. Okay, we're not done taking all of the derivatives, so let's see where we're at now. Again, I have my x squared. In here, I'm going to have x times the derivative of e to the x, which is simply e to the x, plus e to the x times the derivative of x. And again, the derivative of x is simply 1 minus e to the x. And remember, this came from here. E to the x came from this one right here. Minus 2x, the quantity x, e to the x minus e to the x. All of it divided by x to the 4th. Okay, so we've taken all of the derivatives now, and now we need to do at least 2 lines of algebra. So, well, let's see what we've got here. Here's an e to the x minus e to the x. So let's see, inside here, it looks like these are going to cancel, e to the x minus e to the x, and that might make it a little easier. So inside here we have just x e to the x, and then we have 2x, the quantity x, e to the x minus e to the x, divided by x to the 4th. Now if I combine these two, I could have x cubed e to the x, and I have minus 2x. I've got to be careful about distributing this through, because at this point what I'm seeing is that if I have x cubed e to the x minus 2x quantity that I could factor out an x from both of these, and I could factor out an x, and I would have x squared e to the x minus 2, the quantity x e to the x minus e to the x, divided by x to the fourth, and I can do some canceling then with these two factors, and I end up with x squared e to the x minus 2x e to the x minus e to the x divided by x cubed. One last step, I can factor out an e to the x, and I would have x squared minus 2x minus 1 divided by x cubed. Okay, now I just noticed an error that I have. Did you catch it? I forgot to distribute the -2 through there, so let's go back and let's clean up my work here. If I distribute the -2 with that, I would have plus 2e to the x, and factor out an e to the x. This would give me plus 2. Okay. At this point, I highly recommend that you go back and check this with the Inspire. Let's see what we can do with it. Okay, so let's take our Inspires and go to either a new document or a new problem, wherever you happen to be. I'm going to ask you to go to the template palette. And if you notice, there is a template for the second derivative. So go into the template palette and find that derivative. Let me get caught up with what I intended to do here. So, okay. So we need the second derivative with respect to x of, and we have a fraction, and our fraction is e to the x in the numerator, and that's divided by x. So now you could take the derivative of the function and then take its derivative, but we can do this also. And we come up with an answer that looks like this. How does our answer compare? So I'll bring this over here. How does our answer compare? Well, if you look at that, if I break out this as 3 separate fractions, I would in fact have x cubed divided by x squared divided by x cubed, which would be 1 divided by x, and then minus 2x divided by x cubed, which would in fact be -2 divided by x squared, and 2 divided by x cubed. So what we have here is 3 fractions of different denominators. We have 3 fractions of the same. Which is more correct? Either one. Either one. So we're not going to worry about that problem. You have this answer, and I am happy with that answer.